and welcome to the show. Here we are. It's time for John Park's workshop. We're back. So's Lars. I see him right back there. There's Woody, and there's Slappy. They're not really doing much for today's show, but they've got some plans for some upcoming projects, or so they are whispering to me in my ear while I'm asleep. But in the morning, I remember that these guys have plans. That's weird, isn't it? So let's see. We are a go. It looks like YouTube is convincingly giving me both a green light and saying the words "no data." So and now it says excellent connection. All right, YouTube. Make up your mind. Jeesh. I'm gonna give it a moment to settle here and pause some of the little previews that try to pop up off on the side there. All right, let's see how we're doing. First of all, hello everyone for stopping by. Hello Dr. C. Grover, The Love Factory, Andy Calloway, Cup of Coffee, Delicious, Woo-ha 007, Adam Catalak. That's the people over in our Discord. Did you know we've got this Discord right here? If you want to join in on some of this conversation, you can head to the Adafruit Discord server. It's adafruit.it/Discord. That'll give you the instant link to go and join and hang out. And we're in the live broadcast channel. And then over on our YouTube chat, we've got Dave Odessa, Beata Graf Avdalhagen, who says, yo. Randall Bone, hello. Dave Odessa says we're getting some stutter on YouTube, so hopefully that settles itself down. I'm gonna hope so. Hey, Michael F. from the Ukraine, welcome. Nice to have you here. All right, well, I think it's time to kick this thing into gear, right? So let's see. First of all, we'll mention that we have a AdaBox coming up. It's going to be AdaBox 21. Is that right? Is that last one 20? I think so. If you head on over to AdaBox.com, you can find out more. We've got a link there. It says Getting Started. That'll take you to a place where you can subscribe. We have, I think, still just a few subscriptions left on this one. We ship out around 4,000 of these, so we have about 4,000 slots available, and a lot of people tend to bridge that subscription, so we don't get a lot of new openings every quarter. But this one is going to be coming out in October, in about a month or so. We'll start shipping that out. And you can subscribe. You can also subscribe someone else if you want to send this as a gift. AdaBox, if you're not familiar with it, is a box full of fun Adafruit electronics, and we have a lot of tutorials and supporting materials that allow you to build different projects with the stuff in the box. So head on over to adabox.com and you can find out more. While I'm here, while I got this browser up, I will mention our jobs board. If you head over to jobs.adafruit.com, you can look for work. You can look to hire someone to do some work, and it's free of charge in all directions. And we vet these. Actually, Lady Ada and PT personally vet these job positions. So you can be assured that this isn't just anybody who's posting looking for work. Position I noticed on here is a microcontroller C++ programmer job in, and this is a remote one in Hampton, Virginia, custom micro engineering. There's also Black & Decker looking for some electrical engineers and technicians, and exhibit maintenance tech at Discovery World in Milwaukee. That's a full-time job. And there's also this Open Hardware Summit chair position, contract job. If you're in that line of work, well, go check it out. Let's see, one other thing I want to look at. I see a bunch of little noise on the back of the workbench there, and I'm wondering if that's a layer that has green screen turned on. Even though I'm not using a green screen, it has that look. No, it's not. What's that noise from? Is there another layer on? I don't know what that noise is from. That sure is weird. Let's change views. That one's noiseless. Hey, it's gone now. That's good. I don't know what was causing that. All right, so let's see. Oh, look, it looks like Andy Calloway has posted in our Discord that Lars has paid him a visit. Lars is everywhere. Jeez Louise. Doctor says, ah, and also says, I see the noise now that you mention it, but I think it's gone now, yeah? Yeah, that was strange. All right, so that's the kind of thing you can expect from our Discord. So let's see, next up I will mention, I have my product pick of the week show on every Tuesday, and every time I launch this, it has not saved this logo being big. It makes it super tiny. Look, there it is. Let's make it huge, because this is what we're talking about right now. This is the JP's product pick of the week. It's on Tuesdays at 4 Eastern Time, and every week I go over a product pick, something either new or new to me or an old favorite from our back catalog. And I dive into it. We take a look at the data sheet and how to code it if it's something that you code, how to wire it up if it's something you wire up, do some demonstrations, and during the show there is a deep discount on the product pick of the week. This week it was this Neo Trellis driver board. And it was 50% off, which was great. We sold a whole bunch of them because people don't just want one, they want to solder a bunch of them together and make big giant grids. So I usually do a little recap video, and here it is. The Neo Trellis. It's going to run through all of the pixels as purple, then it brings them back on as yellow. And now in order to press the buttons, these are copper contacts that need to be bridged together using the carbon infused rubber that's at the end of each of these little silicone pads. Now you can see when I press one, I just have it turning red while it's pressed, and I have it turning blue when I release. 128 button monome grid. So this is a set of 8 of the Neo Trellis boards connected. Adafruit Neo Trellis. And yeah, I just saw in the Discord, Doctor said I bought 8 to do the bleep bloop, very cool, and ordered just the boards on Tuesday and got the squishies, the little elastomer button pads, in a big order last night, so you got the 10% off. That is maximizing your value. Excellent job. And I'm curious the things people use to or build with those. I'm curious to see what kind of stuff people do. Lighting controllers I've done before, soundboards, MIDI things, and this latest one, the monome grid. And actually, I was talking with someone about this yesterday. One of the interesting things about that monome project, and I think I mentioned. Let me pop back to a web browser to show this. Let's switch out some cameras here. If you just Google Neo Trellis monome, I'm going to do that. There it is. Neo Trellis monome or Neo Trellis monome grid. That'll do it. Oh, just Neo. That should give us Keanu Reeves. Neo Trellis monome. My browser's acting sluggish, so let's see if we can get there. This is harder than I thought it would be. Neo Trellis monome. I'm going to hit enter rather than click up on there. There we go. And let me go to all results. You will get to this right here. This is by our good friend Steve, who goes by OK You're On. This is the GitHub page for this project. So that was the controller that you saw me using. Uses a teensy 3.2. I think it can also use 3.1 and probably a 4. And there's software build instructions here, as well as the physical build instructions. If you look at, I think this Neo Trellis monome, or Neo Trellis monome teensy link, you'll see there's the connections that you can do with it. I'm just noticing in our Discord, Todd said that he wants to build a box out of them. Is that a Hellraiser thing? That'd be kind of cool. That would be neat. I wonder how you do that. I guess you could put some right angle connectors on and cook up a way to things together. Kind of cool. So these instructions here, this is how you can build the thing I built. And the interesting thing about that NeoTrellis DIY monome grid project is that the real product that's based on is called the monome or monome grid. It is rare right now, and I think that might be some supply chain things. So DIY can be good for a lot of reasons, ideally because you want to customize something, put your own spin on it. I'm not usually as big a fan of doing things just because you can do it cheaper than the original, and I think the original is, it's got aluminum plate on it and usually wood sides. It's gorgeous. I'd love to have one, but being able to do the DIY version right now might be the only way that you can get one other than in the used gear market. So kind of cool that you can weather the supply chain storms, at least for now, as long as we have those NeoTrellis driver boards in stock. So let's see what's next. I think it's time. Let's get down to a little project. Or a little CircuitPython Parsec project that I've built and some code I want to show. So let's check this out. CircuitPython Parsec. All right, let me get set up here so I can see my code window. There we go. All right, so what I wanted to show on the CircuitPython Parsec today is how to create a little list of animated servo positions and control a servo motor using CircuitPython. So here you can see the basics of it are that I'm importing some libraries, time so that I can pause, board for pin definitions, PWM, that's pulse width modulation, out so that we can send these signals to the servo to tell it what position to go to, and then the Adafruit motor servo library. We then set up the servo object, and here I've just got one. I'm calling it servo A, servo.servo on my PWM out on board pin A1 is what I've plugged it into on my little feather here, at a frequency of 50 hertz. The minimum pulse duration is 500, maximum pulse is 2,375. These are values you can tune to adjust per servo to get things close to 0 and 180 degrees. Then I'm setting up this little list of animation tuples, essentially, that contain a position, so 0, 90, 45, these are all degrees, and time, how long I want to dwell on those. And this is so that we can do some sort of an animation. Then we have a little variable called animation pose or position, and that's which of those items in that dictionary are we using. And then the main loop of this, we set the angle variable and seconds to be that pair of numbers that come from that list. We print out the value. You can see it printing to my serial port here. Then we set the servo to that angle, so it just jumps to it immediately. I'm not doing anything fancy with easing, which I think I will for a future episode. And then we pause for that time value in seconds, and then we increment using a sort of modulo function to just loop through that list forever and ever. So you can see if I switch over to this view here and plug in the servo, it's been running this whole time, I just didn't have it plugged in. So now I'm going to plug in power, ground, and that PWM out. And now you can see my servo is going to go between those positions that I have, hang out for some various durations of time. I have it moving faster or slower, or holding longer and shorter, I should say. And then looping, so it repeats that motion. So it's a really neat way to set up a repeating animation. So that is how you can set up a list of animation positions on a servo motor inside of CircuitPython. And that is your CircuitPython Parsec. CircuitPython Parsec. So I had some questions over in the chat on YouTube. Question is, hello from Massachusetts. Big Adafruit Feather fan here. What's the controller on the transmitter? Is that a custom microcontroller? Is that open source? So if that's related to this, if the question is about what's going on here, I'll zoom in and you'll see, since you are a Feather fan, you will like this because this is an Adafruit Feather M4 that I'm using. And I hope that was your question. And yes, it's open source. And this, you could do this from nearly any microcontroller that runs CircuitPython and has PWM output on one pin, which I think is all of them. The other thing is that your servo usually wants 5 or 6 volts. So I'm using the USB out, so that's getting USB power off of a powered hub in this case. Otherwise, if you need to power more servos or you need more oomph to it, you can use external power supply, or we also have the Feather. There's a Feather wing for PWM output that includes servos and if you're just doing PWM LED light dimming and that sort of thing. So I hope that answered your question. And let's see, that was coming from YouTube. Let's see, do we have... Doctor says the YouTube does not appear to like it when it moves quickly. I think that was a problem on my my computer. I noticed that too. On my camera output direct from this camera, I can see on a little monitor, it wasn't blurred, but every other place in the chain here on my software was blurring or not liking that fast motion. So I don't know what that was about, but I won't blame YouTube. That was me. Let's see. Good. Okay. So that's our CircuitPython Parsec. Also, this is just a totally off-topic thing. This is a little crossbow bolt from a little crossbow pistol, and it was one of the most fun gifts I ever got. I just I like to go set up a stack of newspapers and shoot the crossbow pistol in it. It's a heck of a lot of fun. So that I happen to have a little drawer full of crossbow darts over here. You don't believe me? Look. Crossbow bolts. Just in case. And I think that's going to do it for our servos. Let me pull that apart off of here. Well, let's see. What's next? The, yeah, Hem says, that or some video compression algorithm going berserk. Yeah, I don't know what's up with that. You know what? I probably am overdue for restarting this machine, which hasn't been restarted in about a week. Bad move on my part, but when I realized that, it was a little late. So, yes, Mr. Certainly, we confiscate all small arms from Lars. He shouldn't have those things. Okay, so now what I wanted to do is get into the project for the week. So this is a little model build and a display stand build for our inductive NeoPixel, not inductive NeoPixel, our inductive LEDs, inductive wireless LEDs. They're not NeoPixels, they're fixed color. It's little SMD LEDs. Let me grab one here. A little handful of them. And that's them right there. I'm going to go to the overhead camera so you can see that a little better. So that's an inductive coil with an LED bolted to the top of it, essentially. And what happens is this locks in with the magnetic field of the transmitter, and it picks up power through the air, much like you can charge your cell phone or your toothbrush wirelessly. Same idea here. And this will light up in a pretty good range of the antenna. It depends on how big the antenna is. So you can see here, if I jump to the bench cam, and let me head on over there, we've got a couple of different sizes of inductive coil power providers here. By the way, I have set up my iPad over here so I can still see the Discord. So if my audio goes weird, let me know. I'll probably see it this time. So here are the two models that we just started selling that are made for this purpose, and these each come with a little pack of 10 of these LEDs. One of them obviously is larger, and this one is runs on 24 volts of DC. and this little one is 5 volt. I haven't powered one of these up yet, so we'll do that in a second. And give me 1 second. I'm going to switch over one of my monitors so that I can see what you're seeing. And hopefully I can focus that. That one's doing some weird flickering now. That monitor's been on the fritz. And I fixed the color channel problem the other day by pulling it apart and reseating a ribbon cable, but it's flipping out a little bit. So if we take this and give it some juice, so I'm going to unplug my little power source here for a second so you can see it. You could use any 24 volt power source. I don't happen to have a lot of them other than like a benchtop supply. And this is a variable power out that we now sell. We have two versions of this. One that I think goes up to 5 volts, is that right? I'll plug that other one in and check it. I can't remember. I think it only goes to 5, maybe it goes to 12. This one goes to 24. So I'm going to plug that in, and then I'll, you know what, in fact, let me grab an extension so that you can see it as I power it on. Where did the plug go? There it is. So here you can see we get lowest is about 3.4 volts, and then it's got this nice little potentiometer on here to dial it up all the way to 24. And what I'll do now is I'll go ahead and plug in the coil. And let me sprinkle some LEDs in here. I don't know how well they're going to, I might have to play around with casting some shadows in here because I have some pretty bright lights. Pop all these up. And these want to be in the same plane. The little coil on the LEDs wants to be on the same plane as the antenna for it to couple. All right, so now if I turn up the power on this, the blue ones come through pretty well. If I put some shadows on here, you can see, dial that back down. So really, these are meant to just stay. I don't think these are really meant to be variable with the power, but once I have that power up, you can move them, as you can see here, in and out of that field. Get it up high enough it won't couple anymore. Grab this green one here. And if I carefully take this coil and I'll hold it planar to the camera, you can see that distance there. So you get maybe 4 or 5 inches away the way I have this set up right now. And they're just plain cool. So one of the neat things about these is they will work through a, there's no contact, obviously, they don't have to be visible and exposed. So what I wanted to do was set up a type of display. And for that, let me just grab I'm going to zoom out a little bit and grab one of these little boxes here. So I have a little sort of hollow-bottomed wood box, and if I take my LEDs out of there for a second, this is about 12 inches square, which covers the coil and the power supply pretty well. So let's unplug this actually and set this up right. So what I wanted to do is make a little shelf. Now obviously you could just hide this, especially if you have a place to duck this over the corner of a table, you could hide this under like a piece of cloth, a tablecloth, placemat, something like that. If you're doing like a magical type of effect or an escape room type of thing, you could probably reduce how suspicious this is by maybe plonking it up under a table instead of having something visible. But I just wanted to make a type of display here. And so if I plug that in, whoa. Did anyone see a spark? I did. That's not good. We should probably turn this off while plugging it in. Let's see if it's still working. It is, okay. And just for the time being, I'm just going to use a little bit of gaffer's tape to tape this up against the bottom so it doesn't drop down. I think some hot glue would work pretty well for this case. Double stick foam tape. And you can see this actually, I bent this at a right angle so that it would fit here neatly, this little wire here. So just do that carefully. This is enamel coated wire. Also, you'll notice that this is going to favor the front. I'm going to call this the front since we have a bigger gap back there, but that's kind of the sweet spot of where we'll put things. And then I'll drill this out in a second, but for now we'll just let this pop out from here. And I'm going to put some Kapton tape around that as well. Let me unplug this. I don't want this bare metal here shorting. I can zoom in a bit here while we look at this. So probably some heat shrink around this would be a good idea. In fact, I think I might have some bigger chunks of heat shrink I could use for that. Maybe something like this is a good idea. Let's do that up. So I'm just going to improvise here a little bit. Hem says, caution, inductive coils can still deliver current after the power is cut. Thank you. That's a good thing to keep in mind. Yeah, the heat shrink is just a little bit long, so I'm going to cut off a chunk of it. That's some heat shrink I got back at Fry's before Fry's disappeared. And I won't actually heat shrink it, but I will. Oh, that's too long because I can't fit over that. Okay, let's just snip it there a little bit. Get past that coil. There we go. So something like that is not a bad idea. And I don't want to leave that LED in there, it'll probably short. And I will still wrap a little Kapton around those exposed wires. Exposed terminal plugs. Nothing like seeing a little spark to remind you to be careful around your electronics. Okay, so we'll plug that in there. Again, in a second we'll drill out for this, but for now we'll just let that be tucked under there. Zoom out a bit. And let's plug the power back in. It might not be a bad idea to add an on-off switch to this, a AC on-off switch, since it doesn't go to 0, it goes down to 3 volts. Okay, so now you can see we've got a LED lit on here. Sprinkle a few of them on there. And there you can see, as soon as they get to about 45 degrees, they will light. You can probably see it better if you see a reflection off my finger of the light. So that is, it depends on positioning a little bit, but you don't have to be 90 degrees, or rather 0 degrees perpendicular to it. You just have to be between 45 and flat, I think works in general. And so that works pretty well, and I'll show you, I demoed these on Show and Tell last night. I made a couple little fun props here. Let me take these loose ones back, put them in a little tray. A little solder sponge tray I'm not using. So that I can tilt this up to camera, since I can't really change this camera too well. And I don't think that front-facing one will zoom in enough. So I've made some little display elements here, such as this welder, this little Lego welder guy. And you can see that lights up there when this gets on the coil, and then they turn off. So I've got a Lego haunted house, haunted mansion that I'm going to try using this on. And in that case, I may be able to bury the coils under the Lego base and behind one wall. But I thought for this type of a display, it would be cool to allow for LEDs that are not within that range of this coil by having a second coil in the back. So you can see here, I've got the Razor's crest. And again, if you look here, you can see those LEDs there. Do I have the remote for this light? Let me try turning off that light. Let's turn off some lights. This will help. Will this turn you off? It will. Okay, that'll help. So now you can see a little better those red LEDs. Well, they turn off when this is facing, they're almost off. I see a little glow. But they're not anywhere near as bright as they should be because of that perpendicular angle. So what I want to do is place a second coil in the wall, in the back of the display. And so this is based on these Gundam model displays that we saw online, where you build your character to have LEDs in the chest and on its feet and on its head and on its weapons. And it doesn't matter which way they're facing, they're still going to light up because we have good enough coverage from these inductive coils. So, hey Steve, okay, you're on, says, did you miss the thing? No, we're doing the thing. We're doing inductive coil LEDs. So here I have a second inductive coil that is going to be in the back wall of this this thing, essentially. And you know what? I think I will switch cameras here for a second. Is this thing on? Hold on, I've got controls to turn on. I'm trying to do this remotely. I have a little trackpad for the computer so that I can get the cursor onto the right application so that I can switch my cameras. Oh, is that working? Yeah. Yeah, that monitor is on the fritz again. So this little back wall here, you can see, has a coil in it, and I've got the coil in underneath the base. And now what I'm going to do is actually use, there's enough current coming from our little power supply here for this. So Adafruit also has these great little splitters for your barrel connectors. So this is like sort of your typical, I think it's 2.1 millimeter DC power connector. So I will move this out of the way for a second. We'll remove our Razor's crest model. I'm going to flip this around so you can see there's my coil. And now I'm just going to plug one end of the splitter here. And again, I'll drill this out later, but for now we'll just let that be wobbly. And now the second coil can plug into the back wall here, which I did not insulate, but it's sitting pretty still. I don't think it's as big a risk, so it's not going to flop around. Okay, and now we can plug in power there. So now we should have both coils running. So if I grab some LEDs, you can see both that blue one on the deck there. Can you see that? I can't see that camera. Yeah, so you can see that blue one on the deck, or green one on the deck rather, and this red one in my fingers. And we have pretty good coverage here. It's definitely possible to find a spot that's no good, but now we have that back wall coverage, which is great. So if I take my little Razor's crest model here, which, by the way, my friend Brian Kessinger, who's a fantastic artist, go check him out, lent me this model to do this with. He plays some tabletop Star Wars wargaming, tabletop wargaming that's Star Wars based. I forget the name of it. And he painted up this great little miniature. So let me switch cameras again here. Now you can see we've got lights if I point it up, and we've got lights if we point it out. See that kind of glowing off my finger there. And that'll cover pretty much any circumstance. You know what, I'm gonna, depending on where your stuff is, yeah, actually I can't do that right now, but you can reposition it to get the coil a little more optimally placed, since there's that sort of little dead zone there. And just looking, let me unplug this one for a second. Just looking at this model, by the way, nice thing is I was able to just plop these in. So you can see Brian did some really nice paint job on some thrusters in there. So it's almost a shame to cover them up. But these happen to fit, just for a quick check, really nicely in there. What I think I'm going to do, though, is a little more of a modification. He said it was okay. So I'm going to pull these off. These were just dry fit in there and then painted, so there's no glue. And we can pop off just this end of the thruster, and then I'll either use some heated end of a needle to pop some tiny holes in, and then we can have some light coming through, or I'll pop out that whole disc there to place the light in there. Also, I think these lights would look really good with a diffuser. Let me see if I have, yeah, this one should work pretty well. Here's a big old 10mm LED. And you can see that these little point light sources are nice and all, but you get some really good glow if you pop sort of that milky LED dome on there, and you can use different sizes. As long as you have a diffuse white or blue LED dome, the blue LED ones are usually white as well, then you can get this effect, which is great. And there's a lot of other things you could use as diffusers. I think some of our little standoffs are nice. See there, we've got these little nylon. Place that, see if I can get it to stay. You get these nice little nylon standoffs that look really good too. Hot glue sometimes works pretty well, depending on the hot glue. You come up with other things for that. Let's see. Someone asked, is the LED removable to instead power a chip? I imagine, yeah. If you got one of these under the microscope, you could probably desolder and put something else on there, something else that is okay with whatever variable current and voltage that's probably getting. I don't know what the regulator is on it. I haven't looked that closely at it. Other questions? Do you have to worry about getting shocked, shorting out, or heat with the inductive coil? It's an excellent question. There's a big heat sink on the coil's power transistor, so you probably need to be mindful of that. So I haven't noticed it getting super hot. In fact, if I take this right now, I don't have a wireless thermometer here right now, but if I unplug this and check, the heat sink is warm but not hot. I can put my finger on there, leave it there. So that's not that hot. But it's an excellent question. You probably want to consider having some environmental cooling, some space for air to get through. No thermal camera. You know what? I'm sure there's one here somewhere. I don't know what the current draw is on the coil. That's a good question. We may have info on the data sheet if you go and look at these inductive coils. The other thing I want to try while we're here is, because it's fun to try stuff live on air for the first time, is the little 5-volt coil. So to be cautious, I'm going to move the 24-volt power supply the heck out of here. And let's move Brian's model over there. Yeah, if you like Star Wars stuff and you like Calvin and Hobbes, Brian is famous for these mashups he does between Calvin and Hobbes and Star Wars characters. They're fantastic. If you just look for that, or look for Brian Kessinger online. You'll find loads of great illustrations from him. So I'm going to take these. So this is the, let me turn the lights back on here. Let me do this. Oof, that's a bright light. So if we want to use the 5-volt smaller coils, and by the way, right now Adafruit sells these. I think we're out of stock, but you can sign up to get an email alert when they come back in stock. These are sold with a pack of 10 LEDs per coil. So whichever one you get, you'll get 10 LEDs. We might sell them separately too, but right now we don't. So in order to power this, you'll need, I'm going to strip just a little extra insulation off the ends here. And I'm going to use one of these, since here's the supply I'm going to use. Does this say? Yeah, this is, okay, so this is 3 to 12 volt. And I'm going to check, before I power that on, I will check what this coil is supposed to take. It might be 5. I think it's 5. Which means you might be able to do it off a USB, depending. So I'm going to plug it into this little adapter. These are really handy, especially if you plug them in right. Screw terminals to barrel connector adapters. And just screw that down. Nice. This doesn't say, does it? No. So let me check. Let's go look at this thing online before we release blue smoke. So let's get back over here. Oh yeah, Steve, by the way, since you joined us, we looked at your Monohm Grid GitHub page earlier. Thank you again for that. So let's go to Adafruit. Ooh, zingers. And let's go to inductive coil. So yeah, that's a 5 volt. The small one's a 5 volt kit. Now it's $15. You get the coil and the set of 10 LEDs. So you'll need a 5 volt supply. Yeah, so I shouldn't really use that variable one, but it's what I have sitting out right now, so I will. But ideally, you'll just use a 5 volt supply. All right, let's jump back over here. And this one's living a little more dangerously because you can send way more voltage than it wants. So let's set that to just a little under 5. That should be good. Let's take a LED or two. Put it in there. Oh, there we go. And you can see that's a nice little glow we're getting from that there. I will turn that light off again so you can see it a little better. Yeah, I've noticed that the red ones don't look as good on camera as the blue and the green. Those really pop. That's the white. There, white. And the set comes with 2 each of 5 colors. So you get blue, green, red, white, and yellow. There's the yellow one. Where'd you go? Oh, that's a red one. There we go. Yellow seems to be the dimmest. White is the brightest, I think. So there you go. That's on the little 5 volt coil. And you can see here, if I'm going to put one on a little Lego plate here. you can see that this one drops off really quickly as we head to the right, and then we pick up the coil again. So I think it's one of these sort of infinity torus donut type of patterns that you get. And then if I'm going up and down, you get about 2 inches away. This is about half the range probably of the big one. But again, you know, depending on the setup, this one being 5 volts, I think is a pretty good candidate for cosplay type of use. So you may be able to put a battery pack, the USB battery pack in your costume, or a LiPo and a power boost, and then you can have glowing things in your costume, maybe infinity stones on your hand that glow when you bring them in close to your chest or something like that. So some cool ideas for, especially with Halloween coming up, as well as cosplay things. Let's see, so we're about out of time. I'll tell you what, I will leave drilling this out and connecting these to make a nice little display. I'll do that offline, but I'll show it to you next week. I'll write up a guide on that. And this, of course, is something that you can decide how you want to build it. So this just happens to be one way, but you could use acrylic panels, coroplast, cardboard, foam core, hide it into a existing shadow box or drawers under a tablecloth. There's a lot of ways that you can get your coil where you want it. And you can even put it, it comes in a pretty big Ziploc bag. You can leave it in there if you want to give it a little more water protection, I suppose. So I think that's going to do it. Yeah, Hem says the 5-volt coil might fit directly in a gauntlet. Yeah, it's kind of cool. So particularly with this one, you can see the effect of leaving the LEDs in place. Turn off this light too. And moving the coil around. So if you have that in a glove or something, a big gauntlet, or in a sleeve of a coat or something, you could do some kind of cool effects, even multiple characters type of stuff. Really neat. So I think that's going to do it, yeah? All right, so let me pop back over. I'm going to turn this off. Unplug that, leave that alone. Whatever capacitor is in here powers the little display. Oh, it went off. It powers it for a good 5 seconds after it gets unplugged. The little matrix was still reading. All right. I think that's going to do it. Other questions? If the coils in the LED was rotated 45 degrees, they might work with the transmit antenna in vertical or horizontal position. Yeah, that's a good point. Yeah, it's all about that. That angle, and it does not have to be exactly flat on. Okay, so I think, let me look real quick if there were a couple other technical questions about the coil, and I want to see if we look at the big one, and where is it? Inductive coil and 10 wireless LED 24 volt. If we scroll down in the product page, we should have a additional technical info. Okay, this doesn't have a lot on it. So voltage is 24, power distance is 0 to 150 millimeters. The module size is 18 by 30, and then the actual coil is 200 millimeter diameter. So that's all the info we have on that. If you wanted to find out current draw, then you might need to hook that up to a meter. All right. Well, I think that's going to do it then. Thank you so much for stopping by today, everyone over in the YouTube and on our Discord. Appreciate you stopping by. That's going to do it for this episode of John Park's Workshop. I'm John Park for Adafruit Industries, and I will see you next time. Bye-bye.